Well, we talked about the moons of Jupiter. Let's talk about the moons of Saturn. Saturn's most famous for having a big ring system, but it also has a large number of moons. And so we've got one big moon, and then a variety of medium-sized moons, and then a whole bunch of small moons. When I was young, Saturn had the most moons in the solar system, and Jupiter was second, and so forth. And so that's how I learned it when I was in elementary school. And then they started discovering more and more moons around Jupiter, and that displaced Saturn as having the most number of moons. In recent years, though, Saturn, more moons have been discovered, and so it's retaken its lead in terms of number of moons. Now, if you remember, the ring particles themselves can be thought of as moons, because the rings themselves are made up of little small icy chunks that are moving around Saturn. So you can think of them as little miniature moons. Well, this raises a big question then: what counts as a moon and what counts as something else? So what is the smallest thing that can still be a moon? Is it 100 miles across, or 10 miles across, or 1 mile across? 500 feet across, 100 feet, 10 feet, 1 foot? What if it's a chunk of rock just a couple inches across? Is that a moon? And so the IAU was in this huge debate as about what counts as the definition of planets. I think a bigger problem would have been definition of moons. And Saturn epitomizes this problem with defining moons, because the ring particles themselves are naturally occurring satellites orbiting around Saturn. 82 moons have so far been discovered. Not all of those have been named. There's actually a number of these moons that have been discovered fairly recently that they're still trying to figure out how to name them. And so Saturn has a handful of moons that are just simply called S something's number, for that moon of Saturn. And so there are a number of these that are that don't have names. Of those 82 moons, only 13 of them are more than 50 kilometers across. That's like 27 miles or something. And so that means that most of them are little bitty small things. Nonetheless, there are a number of them that are fairly large. And so, as I said, for a long time, long before they discovered the moons of Mars, they knew of about 8 moons of Saturn and 4 moons of Jupiter. I said that in an earlier lecture. In addition to those 84 moons, there have been about 150 moonlets, little tiny things, solid objects orbiting around Saturn within the ring system. Now remember, we had talked about the Roche limit, the distance you have to be away before something can fall apart. Well, the smaller something is, the easier it is to hold itself together, and so it can be inside, a small solid thing can be inside what would be the Roche limit of a bigger moon. And so there's about 150 of these little mini moons orbiting around Saturn. So in addition to the 84, what we generally recognize as moons, only about 24 of all these are considered regular satellites other than the moonlets. The moonlets orbit in the ring system, so that means they do by default orbit over the equator, so very low inclination and also pretty low eccentricity. Of the 82 confirmed moons, though, only about 24 of those are considered regular, meaning that they have low inclination and low eccentricity. The biggest of all the moons is Titan. Titan is huge. It is about the size of Ganymede and contains 96% of the mass of all the stuff orbiting Saturn. So Titan is by far the king of the moons of Saturn. Titan is sometimes regarded as one of the biggest moons of the solar system. Mimas is an interesting little moon. We'll get back to Titan later. Mimas is an interesting moon because it turns out that Mimas has an orbital resonance with the gaps in the ring system. So it's the gravity of Mimas that's clearing out some of those gaps, kind of like the way that Jupiter clears out the Kirkwood gaps in the solar system. When the Voyagers flew by and took pictures of Mimas, it was really fascinating because the first pictures that came back right about the same time as the first Star Wars movie was released. And so what happened was all of us sci-fi nerds, quickly looked at Mimas and recognized, hey, that thing looks a whole lot like the Death Star. It's one of the smaller moons in the solar system that has pulled itself into a round shape. It's probably low mass, and it's just about 400 kilometers in diameter. Get much smaller than that, and then gravity doesn't win, and it still becomes in a regular shape. Now, the most obvious thing about Mimas is that giant crater right there. They named the crater Herschel. And so a giant impact happened there. Shock waves went through Mimas and actually disrupted the ground on the far side. The ground on the far side of the moon was disrupted by the shock waves that went through. The ground rebounded in the middle and gave that mountain peak that you see right in the middle of that crater right there. Dione is an interesting moon because it has these wispy patterns on it. The wispy lines are on the trailing hemisphere, and as it goes around, and you notice that the ground looks different on one side than it does on the other side. One side is very, very rough, has lots of craters in it, meaning the ground is pretty much unaltered. The other side has craters, but all those wispy things there turn out to be ice cliffs. Possibly because the inside the moon is shifting somewhat. And so as it shifts around on the inside, then that cracks the surface. About half of the mass is silicates. The rest is water ice. Well, silicate's way more than water ice. So that means that most of it is water ice. This far from the sun, water is a major constituent of the building blocks of something. So water is like rock. It's the third largest moon around Saturn and is larger than all of the smaller moons combined. So it's a pretty sizable sort of object. So that means we got Titan, the biggest moon, and then we have another moon, we have Dione, and then have a handful of little bitty ones, and then we have the rest of them, which are tiny. Tethys, another one of these moons here, very low density, almost all water ice, probably 95% water ice. Now that's really a surprise because we expect when we're this far, from the sun, we'd have a mixture of rock and ice at this distance. This has almost no rock in it. It's almost all water ice. It's got several big cracks in it, and possibly, as you know, when water freezes, it expands. So the outside would get cold first and freeze, then the inside would get cold, and as it froze, it would expand and crack the surface. And so we suspect that may be what's happening with Tethys. Now, two weird things here, Telesto and Calypso. Just little tiny specks of moons. They don't really amount to much. The weird thing is they're actually in the same orbit around Saturn as Tethys. So we got Saturn, we got Tethys around here, and we got Tethys, and 60 degrees in front and behind are Telesto and Calypso. And so what does that mean? Well, remember the Trojan asteroids that orbit the sun 60 degrees in front of Jupiter and behind Jupiter? That means that these two asteroids right here are a similar concept, that these are like Trojan sort of orbits. So 60 degrees in front, 60 degrees behind, so they share the orbit with Tethys. They're just tiny little chunks of rock, irregular in shape. They probably would not be of any consequence, to study other than they were co-orbital. Got two other co-orbital moons that were kind of an oddity, and they were Janus and Epimetheus. And Janus and Epimetheus, interesting sort of thing about them is that the orbits are only 100 kilometers apart. Well, that's not exactly co-orbital. One's a little bit closer to Saturn than the other. But notice the size of them. The size of them is actually bigger than 100 kilometers. So that means that if they're only 100 kilometers apart in orbit, they're not big enough to get past each other. Well, obviously, the inner moon is going to go around quicker than the outer moon, and so this leads to a problem. How does the inner one get past? And in fact, when the Voyagers discovered this, they saw that the inner moon was getting close to the outer moon, and they thought, well, they're going to collide, and when the second Voyager arrived, it was going to see a new ring system. Well, when the second Voyager arrived, the two moons were still there, and they had interchanged each other. So what happens? Well, what happens is that the inner moon comes up and catches up with the outer moon, which is ahead of it. Now, the gravity of the two pulls so that the outer moon pulls on the inner moon and speeds it up, so it goes to a higher orbit and slows down. The gravity of the inner moon pulls on the outer moon, and it slows down, falls to a lower orbit, and goes further away. So what happens is the moons interchange orbits when they get close to each other. And then a number of years later, the inner moon catches up with the outer moon again, and they exchange orbits again. So they get close together, change orbits, pull apart. And then after a while, they get close together, change orbits, and pull apart. So this was our first example of this sort of thing happening. As we get out into the solar system, we keep seeing weird things, and so the scientists at the Jet Propulsion Laboratory, which oversees these interplanetary probes, they started joking that they had seen everything. Then they saw this and said, "Oh, well, we haven't quite seen everything, but now we've seen everything." And then they saw other weird stuff and said, "Well, now we've seen everything." And then they saw more weird stuff. Really, I think they should quit saying they've seen everything, because there's still weird stuff that's out there yet to be discovered, I'm sure.